And in theory, there we go. Now it worked. I think. Yes, we have video. Okay, perfect. I don't know quite why that was so temperamental tonight. I'm not sure what I did. Did incorrectly there, but it looks like it's up and running now. Sorry about that for the folks over on the YouTube side. It's a little hokey sometimes. All right, let's see. Hey, I've built a software rasterizer, both in OpenGL and without libraries. Do you think I can start your game engine series from the beginning? Thank you. Yeah, I would say so, probably. If you have OpenGL experience, and especially if you've done it without libraries, then yeah, I would definitely say you should be able to start the series. Yeah, for sure. I try to do my best to explain Vulkan enough to where it makes sense for the application that we're using. It's not necessarily designed to be just a pure Vulkan tutorial. Vulkan is sort of an aspect of the game engine, right? So it's definitely not a complete Vulkan resource, but we do touch enough Vulkan here that you should definitely be able to go with it, right? So yes, to answer your question. Good. Thanks. All right, cool. Thank you so much for the tier 1 subscription. I'm holding it. I appreciate that. Thank you. Definitely appreciate the support there. Thank you very much. Got it. The series looks amazing. Yeah, I hope you like it. We've been going at it now for a while, and it started off as a sort of a tutorial series on YouTube with sort of shorter content videos, but the engine eventually outgrew that kind of format in terms of scope. So now we do it this way, and there is some stuff I have to do offline, but whenever I do it offline, I make sure to review it like this, right? Okay, so this was the first of one of those 2 commits, and then the second one is not very big either. I think this was just had a couple of refactorings and bug fixes, so nothing major here. So the first part of this was in our image loader. When we were querying the properties, we were defaulting the final result to false. We should have been defaulting that to true, and then hitting false in an error scenario, right? And so that's just what that's doing. And then we have in our resource types, we just added a texture type count. So that way that's always the last entry in that enumeration. So that we can actually have a count as to how many types we have. That's used for that static assert that we saw before. And then we've done some refactoring. This is probably the biggest piece of this is in the material system. So we had all this crazy stuff up here about our terrain sampler counts and all that stuff. Now it's just one sampler for the array of material textures, one sampler for the shadow map, and one sampler for the shadow map array, and one sampler for the irradiance map, right? So this is a layered texture, this is a layered texture, and this is a cube map. And you'll see the results of this in the shaders. We can pull those up and quickly look at those. So all we do here is we just set the index of this to 0, and then we add this. We just offset it by 1. And then we use shadow map to offset that by 1 to get the irradiance map. So they're always in order no matter how they're defined. And then what we do is we have changed up our logic in terms of how we actually get the materials. So before we were actually doing a material system acquire, which actually loaded up not only the configuration of the material, but loaded up the materials themselves that the terrain was actually going to use, extracted the textures from those, and then threw away the materials. And we're changing up the way that we're doing that because we have to change the way that textures are loaded irregardless, right? So with that, what we wound up doing was just loading up the material configs instead, and just extracting the map names out of that, and then unloading that material resource, right? So we're basically just we're loading up the config, extracting the texture names if they exist, and then throwing those things away, right? Ruche with the Yar bongos, I appreciate it. Love the Yar bongos. All right, so that also replaces all of this logic that we had here. So before, what we had to do was we basically had to loop through the materials and sort of assign the textures to each one of the material slots. And now, instead of doing that, our map is actually just one single map for the entire thing. So what we do is a single call to that thing that we wrote on the last stream, which is the texture system acquire textures as arrayed. And what that does is we just pass in the texture names that we gathered earlier. And this is what is responsible for loading that layered texture. So we don't have to feed it all in here and anything like that. This function just handles it for us. And of course, we have some failure detection here for that, with the ability to get a default terrain texture, which is also a layered texture, if that fails, right? So we'll see that when we get down to the texture system. So what we wind up here with is actually a lot simpler code, right? We don't have all this complexity here. So we're able to eliminate all of that stuff. We still do have to acquire texture map resources, but for only one map, not like 12, right? And so that's much, much better. We also then do some cleanup here where we release those texture names in the array. And then we free the texture names array itself. When we acquire a terrain material, we no longer, this is further down in the same function. We no longer have to release the reference materials because we never loaded them in the first place. So that's gone. And what we've done is we also had to change up our shader instance uniform texture config for our material textures. Now there's just one map. We only need to load one or resources for one, right? So we don't have to do any of this stuff anymore. We don't have to go through per material or any of that. It's just a single map, right? So it's much easier from code to handle it this way, and faster too. Otherwise, when we, one more change is in the material system, when we apply the instance, we don't have to loop through the material maps anymore. It's a single map, right? When we are, when we are creating a default PBR material, I fixed an issue in here where our default material, which is the checkerboard pattern, if you recall, was using linear texture filtering, which doesn't really make sense on a checkerboard, right? I don't think this completely fixes the issue, but that's what that's doing, right? I think there's one more thing I actually have to change in order to get that to work, but for now, this is just sort of part of that change. So the other thing that we did was when we are creating the default terrain material, before we had just one material, here we're just going to max it out, right? We're just going to assume max materials across the board. And the reason for that is because we can get this texture system, get default terrain texture. And that comes with a maximum amount of texture data already loaded in it. So we don't have to get all these individual maps. We don't have to loop through all this, all the materials and stuff like that. We don't have to do any of that stuff anymore. It's just one map that gets loaded with a single texture. And again, with the nearest neighbor filtering. And then we have the same change here. So we no longer need multiple texture maps. We just need one. And again, we don't have to go through every material. We just set the single map, right? So that's pretty much it for our material system updates, right? So there's that. Let me just collapse some of these so it's a little bit easier to keep track of where I am. All right, so let's come back to the C file. I'm going to go over the interface level changes first, and then we'll look at the implementation of that. So in the texture system itself, we have this new acquire textures as arrayed. So this acquires a arrayed texture, taking in all of these texture names, right? And so basically what it does is it takes the texture names in that order and loads them into a array texture. So one texture per layer. The requirement being that all the textures that you use for this all have to be the same size, right? So that's all spelled out in the comments here. Nice freeze. I'm not sure how to pronounce that. There's a random X in there I don't know how to pronounce. But I appreciate the follow. Thank you for that, and welcome. All right. So the other thing that we added was just the ability to get a default terrain texture, right? Which is basically just one of these guys. So on the surface, that's all that changed. Underneath, however, we've written whoops, I meant to expand that. We've written quite a decent chunk, right? So we added a default terrain texture to our state. And then we split out the process texture reference and the create texture, right? Before this process texture reference, which is what adds and removes textures from our internal texture hash map lookup table, where we keep all of our texture references or texture reference counts and all that stuff. We separated that process from the actual creation because initially it was kind of doing both. And so we separated that out so that process texture reference only takes what it needs to deal with the reference, and then create texture takes what it needs to actually create the texture. So most of these updates are revolving around that. Let's see. We also, looks like we did away with the, when we're loading the cube textures, we did away with the name of that texture, right? Because it wasn't necessary. It's being set somewhere else anyway. So we removed that parameter, and now we just have the names of the individual textures, right? Okay, so similar to other systems that we have, when we process the texture reference, we can pass in a flag as to whether or not it needs creation. And basically that is if we are saying we want to acquire a texture by name, and that texture has already been loaded, already exists, all we do is up the reference counter, and then we say we don't need to create this texture, it's already created. If we were to load a texture or acquire a texture that isn't already loaded, then this would be set to true, right? So most of these changes, process texture reference is going to be us just changing up those flags, right? And then we check to see if it needs creation, and then we call create texture, passing in all of that data that we need. So that's going to be things like the texture handle itself, the type of texture we're going to create, width and height, and channel count if we're not loading a texture. So this is for like writable textures, things of that nature. For a texture that is being loaded from file, we extract that information from file. So it doesn't actually matter what you pass there. So that's why those things are zeros here, right? We also have the array size, which is typically going to be 1 unless we're talking of an arrayed texture, because this all flows through the same logic now, right? So in a lot of cases, you're going to see a 1 here. You might see a layer count there. You'll also see layer texture names. So this is an array of strings. Obviously, if that's not needed, we can just pass 0. And then we pass whether or not it's writable texture and whether or not we should skip the loading process. So writable texture just sets some flags in there to say, hey, this texture can be written to, and then make some adjustments in the memory and on the Vulkan side. And then skip load basically is for textures that don't have a file associated with them. Like writable textures typically follow into this, but not always. Okay. So you'll see this repeated pattern a lot. Just the things here get changed. Most of them should make sense, right? This one's for a cube map, right? So we load, we process the texture reference, and then we load a cube map. Writable arrayed, it's kind of the same thing, right? We actually remove some dimension, or remove some to-dos out of here and some notes. But this is kind of the same thing, right? So we process the texture reference, and then if we have to create it, we take in the specific type of texture here. So The texture type for a writable arrayed is actually provided as a parameter, so we just pass that through, right? Acquire textures as arrayed. This is sort of a new one here, right? So this is that one that we added. So this guy, again, processes the reference. If it needs to load, it is treated as a 2D array texture. If we have a 3D array texture or a 1D array texture, we'll probably have a different entry point for that. Okay. Let's see. So texture system release still uses process texture reference. It's just the increment is -1 now, so we're decrementing essentially. It still requires a creation flag even though it's not used, so we still have to provide that. Wrap internal is basically the same thing. That's always going to be false. We know that, but to meet the interface, it's got to provide that. We added to the is default texture, we added the default terrain texture to that. Here is the sort of requester or the getter for the default terrain texture. So basically all it does is returns a pointer to that, or bleats if the texture system hasn't been stood up yet. And then create default texture always works with an array size of 1 by default now, unless it is a cube map, and then it works with an array size of 6. Then we have a create default layered texture, which is specifically for layered textures. And so it defaults to a MIP level of 1, which we may actually want to change at some point. But this is for a default texture, so I'm not too worried about it. And then it takes in a layer count, and then it goes ahead and just creates that those pixels, using the pixels that are passed in, right? So this guy takes the texture, the layer count, a blob of all layers pixels, so a single block of memory, and that whole thing basically gets stuck in all at once, right? And then it takes the texture dimension so that it knows how big it is, and uses that information to populate the texture, right? Create default textures. We just added a default terrain texture. So the way that this guy works is we have 4 materials, and our terrain per material count is 3 right now. And so we get a layer count from that, which is going to be 12 in this case. And then we calculate the terrain pixels, which is basically that huge block of memory that includes all of the 12 layers of image memory. So we allocate that. We go ahead and say the material size for each one of these materials is the size of an individual layer, which is 16 by 16 by 4 times U8, right? So this is a U8. We have 16 wide, 16 high, and then 4 channels, right? So we take that times the layer size, and we multiply that. We multiply that rather by the material map count per material map count for terrains, right? So we loop through each of the terrains, and we grab a albedo for that, a normal, and a combined map, right? And all we do is just memory copies into that block of memory, right? And we basically just do albedo, normal, combined, albedo, normal, combined, albedo, normal, combined, albedo, normal, combined, right? And that way the memory is laid out correctly, and then we can call create default layered texture, which is what we saw before, and that just loads that all to the GPU. And then we can go ahead and free the terrain pixels, okay? So that's the creation of that default terrain texture. Obviously, we're creating that, so we have to destroy it when we shut the system down. Here is the removal of the name when we load the cube textures. The name is copied in at a different point, so we just eliminated that. And the other thing is we actually had an incorrect result code if image loader query fails, right? So we just changed that, fixed that bug. We set the typed result out texture to the load params out texture. So that's basically just copying over a pointer to say that this is the texture that we're loading into in the end, right? Let's see. We copy relevant properties from the original texture. So these are just some property copies that we are missing. The type, ID, and flags. We also take the array size and copy that to the temp texture, right? And then we create the job and fire it off. Okay, so this is the create texture that we split everything out to. And you'll notice that this is a lot simpler too, because it's not buried in all that that resource counting logic, right? It's sort of its own thing now. So we copy over the type, the array size. If it's writable, we set that flag. If we're not loading, we go ahead and set the width, height, and channel count. Otherwise, we ignore them. If it's writable, we set the MIP levels to 1 because we don't really need to MIP map or generate MIP maps for writable textures. It's kind of ridiculous, right? So if it's writable, we create a writable. Otherwise, we just create a standard texture, right? And then here is if we are not skipping the load, and I think we're going to have adds here in a second. So if we need to actually perform a load, here's our load from cube textures, right? This hasn't changed from before. It's the same thing. And then if we have a 2D or 2D array, we send both of these to the load texture, right? They both work the same way. Layer texture names is populated if it's passed in here. Otherwise, it's 0 if it's not, right? And then same with process texture reference. It just defaults needs creation to false. And then if it's found that it needs to be created, it sets that to true. So here's all that logic for loading removed, right? And basically it says here, if we expand this up a little bit, if we have found an, we have adds. We're almost done. Almost made it. All right, so for those of you who are new to the stream, we like to break for ads. We're served ads on the Twitch side at least every 30 minutes for 90 seconds or up to 90 seconds, depending on where you are in terms of region or locale. So I like to pause the stream so that nobody misses anything. It's only 90 seconds, and then we continue from there. So over on the YouTube side, Bad Comic, hello. Welcome to the stream. Hope you're doing well. Incidentally, folks over on the YouTube side, I do watch chats on both sides. So this is an interactive stream. So if you feel free to chat, as long as it's related to what we're doing here on the channel, at least loosely, right? You just woke up, nice. Are you in a different time zone or something? I'm Eastern Standard. Eastern Standard, or yeah, it's not daylight savings. Yeah, Eastern Standard right now. Small animator. One day will the engine use I am GUI? Give me 5 seconds and I will answer that question. I just want to wait for ads to end. Okay, ads are dead. Small animator over on YouTube asks, one day will the engine use I'm GUI? So the way that this engine is architected is a lot of things are left out of the engine core and are left up to plugin development to happen. And that keeps a lot of things out of the engine core, keeps the engine core small and tight. The reason we do that is also flexibility. So our renderer, for example, our rendering backend or Vulkan renderer is a plugin. Our audio system is a plugin. And so even our UI system that we have, that we've already started developing, which is, I call the standard UI system. That's what contains currently our button, our text box, controls, things like that you might find in like a standard desktop application, but not necessarily a game. Even that is a standalone plugin library. And the idea is that applications can choose what they include and what they don't include. So, for example, you might have, in your game, you might not need text boxes and like standard UI buttons like what you see on the screen here and stuff like that. You might not need that in a game. You probably don't, right? You probably don't need all of that overhead and all of that stuff that comes with it. And so in your game, you might not include that, but in an editor, you might, right? And so both the editor and the game are separate applications that use the engine, but they have different requirements, right? And so you could even set it up in such a way where maybe your game uses the standard UI for a debug build, so you can have a drop-down console for debugging, but maybe on the release build, it doesn't include it, right? And so this is a long-winded way of saying we could essentially create a wrapper around that and a plugin for Kohi that includes IamGui at some point if we wanted to do that. But we don't have to, and the engine doesn't need to know anything about it. It can be completely external, right? Doesn't even have to be developed by me. It could actually be developed by somebody else, right? So that's the idea behind that. So will the engine itself contain it? No, but a plugin might. Apotham, hello. Welcome to the stream. Good evening. How are you? Good to see you. So we're just finishing up with the push of code that I did earlier. And so our last bit here was basically where we had removed all of the loading logic out of here. So the only thing we do now is if we have determined that a free slot has been found and we're creating a new texture, all we're doing is flipping this flag of needs creation to true and taking a copy of the texture name at that point, right? And at that point, that'll get handed off to the separate function that's been written to do this stuff. So it's a little bit cleaner of an implementation, all right? So those are the two things that were pushed over, I guess, between the last stream and this one. And then we've actually made a number of changes off camera since then as well. And so I will go over those really quickly, and then we can actually run this and see what it looks like, right? Which it's not going to look a lot different, a little bit different, because of some stuff I fixed. So actually, let's take a look at the changelog first. So I like to do this so that I remember everything to talk about with you guys, right? So I actually fixed a bug in the directory parsing, where we take a string that's got a full path and we get the directory only out of that. I fixed a bug in there where the string was not zero terminated. I don't know how we've gotten away with it thus far, but it reared its ugly head when I was doing some testing, right? And that was why I was doing some testing around this next change, which is where we fixed various OBJ MTL or OBJ material loading issues. And we added conversions for the new PBR map type. So we hadn't updated that to use PBR yet. It was still basically going to import everything as Fong, which isn't supported anymore. So we went ahead and fixed that. We fixed a issue in the shadow map, both in the shader and the pass, where the albedo textures were not being sampled. Which basically meant if you had something with transparency in it, that transparency wasn't being taken into account when casting shadows. And so now it is, and we'll see what that change is. I also added a test tree model resource so that we have something to test this with, right? And then we also did a fix where point lights are now unaffected by directional shadow maps. So basically, directional shadow maps before were completely also canceling out point lights, and now they don't do that anymore. So that's essentially the scope of changes that we made. This looks like a lot of files that have changed, but a lot of these are assets, okay? So these are the two materials that were generated. This is the static mesh that was generated. This is the material file that was imported, the OBJ mesh file that was imported. And then, let's see, these are the textures that go along with that new tree mesh, right? So that's like half the files right there just by itself. We also edited the test scene to add the tree and also slightly changed the position of one of the point lights so that we can actually see the changes that we've made. This was the fix for the directory path not being 0 terminated, right? We literally just had to tack a 0 onto the end of that string. We were forgetting to do it. So that's that fix. Resource types, we also added a cube array texture type, although we don't support it yet. I will go into the reasons why we added that in a moment. Let's see. Let's do... So version is just a version increment. Nothing really fancy to see there. Let's go to the mesh... Actually, resource system first. Let's see. I think I literally just added to this. It includes a trailing slash now, right? Because that wasn't in the comment, right? So that's that. Mesh loader. So mesh loader just had a few small tweaks. We do a string trim when we are taking in or generating the full material path, right? So that is for the full material path for the static mesh, right? And then down here, we added and changed a couple of the maps, right? So now we have albedo, metallic, roughness, and emissive, which we don't support yet, but we support the import of it, right? So right now this will be ignored by the material loader, right? The other thing that we have to do, and perhaps I should add a to-do here. I'm just going to do that actually, is we need to combine these maps on import, right? And so we actually need to run a process on these, the metallic roughness and the AO, right? Which OBJ I don't think actually supports AO. Maybe it does, and I just don't know what it is. But here are the fields for those things, and then we read them in, right? And so we would need to run the combination process against those or the default versions of them so that we have a default map. Because that would have to be done manually at the moment, which is not ideal. The stuff that we imported did not have those maps in it, so it's not a problem, but it will be a problem as soon as we actually go to do that. So that probably needs to be one of the next things that we actually attack. Okay. The other thing was we hit a bug in here when we hit a name in our material file. We write out a KMT file, which is a kohi material file, with what we've read up to so far, and then we reset the material, right? So we release the arrays, zero out the memory of the structure itself for the current config that we're sort of working with. And the issue with this is up till now, all of our material files or our MTL files have only had one material in them, but they're technically material library files, meaning they could have multiples. And so our code didn't exactly handle that situation. So what it needed to do was actually recreate these, right? So we recreate these arrays, and then it seemed to work okay. When we go to write the KMT file, which is the kohi material file, that's I'll pull one of those up in a second. We basically had to switch around some formatting stuff that we did. And we could actually use our new resource system base path for type. Instead of having to do all this stuff, we don't have to do all that hackery anymore. We can just read from the base type itself, right? So we take the base path for the material resource type, and then combine that with the name of the configuration that we're loading, and then tack on a KMT for it, and bam, we have our full path. Last thing that we did here was we changed the output type from Fong to PBR, and that's it. So there's that. Oops. And just a couple more files here. We've already touched on all of these except for shadow map pass. And again, you can see there's not very many changes in here either. This is mostly just tweaks, right? So we added D-array. We added a shadow shader instance data that takes, or that keeps track rather of render frame number and draw index. And the reason for that I'll explain in a second. We also keep a an array of those. And then if we come down here, when we're looping through all of our stuff that we need to draw, and we're taking the highest instance ID, whenever we do that, and if that number has changed, what we do is we blow away that array if it exists, and then create a new one of that size plus 1, right? And that will basically hold our instance data. And the reason that we need to do that is because when we are applying instance level data, actually I'll show you this in just a second. So we default those things here, right? For each individual instance, right? So we default those to invalid ID. Then down here, we actually can't update the materials frame number / draw index because it still needs to be used for the actual scene render. So we can't use internal data shader render frame number, right? If we did that, that would sort of be the global one, and that's bad, right? So we can't use that one. We can't use the one on the material either, because that needs to be used in the next pass. So what we do instead is we track this locally within here, since these are sort of fake instance numbers, and we do that instead, right? So I can delete these comments, get these out of here. All right. So that is actually all the updates for the shadow map pass, right? Nothing huge, just kind of little bug fixes. And then the rest of the changes are actually in our shaders. So let's see. We'll do the shadow map first. So the shadow map was not taking into account the color map or the albedo, right? Which is what we need to use for transparency. So we calculate the alpha from that. And you can see here that I had this commented out. I just wasn't actually using it. The out color we basically set to white, and then use that alpha. And then we also say if alpha is less than 0.5, we just discard the fragment, right? We don't use it. And that gives us a really nice result. We also had to change the binding from 1 to 0 because our shader config, if we take a look at that, the only thing that's local, right, or scope 1 in this is the color map, right? There's no UBO here. So it's got to be binding 0 instead of binding 1 like most of our textures are, right? So that's that. And then our PBR shader, this looks like a big change, but it's actually not. I just moved some code. So what we've done, what we've done is down here at the bottom, let me shrink some of this. So down here at the bottom, we were doing all this calculation to get what the shadow should be, right? So we were figuring out the fragment position in the view space, figuring out what the depth from the camera was, then going through and figuring out all the cascade split stuff, our cascade index, and then calculating our shadow, right? And that would give us basically, are we in shadow, yes or no? Or, anywhere in between if it was sort of being interpolated, right? And so all we did was we basically took this entire block of code and moved it up to above where we actually use it, right? And so the reason that we've done this is because we don't necessarily want the shadow to affect all light types. And actually, I probably could move this. I probably should move that inside of here, come to think of it, because we don't necessarily need to run this in view 2 or in mode 2. But anyway, so if we are in mode 0, which is normal rendering mode, mode 1, which is lighting only, or mode 3, which is the sort of debug shadow cascade, if we are in any of those modes, then we actually use that, right? And so what we do is we calculate the shadow value as part of the reflectance for the directional light only, and it does not affect the point lights, right? And so what that gives us is that fixes the bug where we were basically killing the total reflectance of our point lights with our directional shadow map. And so that change has been applied to both our terrain shader and our PBR shader, right? So it's the same change. Madamente, thank you so much for the raid of the party of 10. Thank you so much. I appreciate that. How are you doing tonight? What were you working on? What were you up to? Let me do a shout out. Appreciate the raid. And I will also toss you a follow. So, for the raiders, for the benefit of the raiders, I'm going to just give a quick intro to what we are doing here. And then I'll actually show you guys a demo, which is, you guys had really good timing actually dropping in. Because I was just going over some changes that I made off camera, and we'll actually be able to demo those here in a second. But before we get to that, so what we're developing here on stream is called the Kohi Game Engine. So it is a game engine built, I should say, almost entirely on camera. We go over all the code on camera at a minimum. But this is a game engine written from complete scratch using C and then Vulkan as its initial rendering backend. I say initial because eventually we'll be supporting others like Direct 3D, Metal, things of that nature. And so the idea of this one is that it's supposed to be like a learning exercise. It started off as a tutorial series, and then it just basically morphed into the live stream that we have here today. And so this is a completely free and open source engine, so it's available on GitHub. So if we take a look at that, in fact, I'll drop a link here in chat for you guys to see. And so if we take a look at this, it is Apache 2.0 license, which basically means that it is free for you to use however you see fit, commercial or personal. All I ask is that if you use the code, just mention that you used it. That's it, right? So there will never be any sort of royalty fees. There will never be any fees whatsoever or cost to use this engine. It is 100% free, and it always will be. That is never going to change. It's always going to be an open source engine as well. Okay, so yeah, that is that. And then let's see what else. Basically, the engine is a couple years into development. It does take some time because I do work on this in my spare time. So I don't have the ability to work on this full time. So it's not moving quickly per se, but we have accomplished quite a bit. So for example, if I look at my to-do, this is the more or less roadmap for the whole thing. And all of the tick boxes here that have an X in them are things that we've done. The ones that are empty are the things that we've not done. And so there's quite a few features in here that we've actually done, but there's plenty more stuff that's actually planned, right? And so the idea behind this engine is it's also completely modular. So let me just collapse some of this stuff here. So the idea is that our engine core is essentially a shared library, right? So for Windows people, that's a DLL. For Linux, that'll be a .so, and then for Mac, it's a dylib, I think it is. And so the idea is that the engine itself is consumed by an application. So our application that we're using right now is what I call testbed. And so the application has a reference to the engine itself, as well as any plugins that it wants to use. I'll get to that in a second. So the testbed lib is where the game code resides, or the application code. You can think of it that way. So that's the application-specific logic. And when I say application, I mean it could be a game that's using the engine, or it could be something like an editor, which we're eventually going to be building as well. And so both of those have very different needs between them. And so they can be configured and have their own separate sets of application-specific code. The application-specific code is hot reloadable, so you can sit there and edit the logic, change the logic, and recompile it, and the game will reload it on the fly. And then a lot of our main systems in this are actually plugin based. So the idea behind this is that the application knows what it needs and what it doesn't need. So our renderer, our Vulkan renderer, for example, is a plugin. We'll eventually have a direct 3D renderer. We'll eventually have a metal renderer for Mac OS. I don't think I mentioned this, by the way, but it is cross-platform compatible. Windows, Mac, and Linux for right now. And so, for certain builds or certain platforms, you may want to use one renderer or the other, for example. Our audio library is a plugin as well. Our UI system, which for right now we're calling standard UI, that contains like your buttons, your text boxes, stuff like that. Those are in the standard UI, and that is also a plugin because you might have some applications that want to use it, some that don't. And so that's kind of the whole premise that we're developing this entire engine around, is sort of this plugin architecture where you've got this engine core, but then you've got plugins that give you the functionality that you need. All right. Planning an OpenGL renderer as well? Maybe. There's not as much value to that, I don't think, because between Direct 3D and Vulkan and Metal, that really covers all the bases, right? So maybe for legacy purposes, but yeah. Plugin based sounds a lot like Bevy. There's a few engines out there that do it this way. Godot is another one that's pretty plugin heavy, right? Let's see. Let me just scroll back up here in the chat for a second. My stream is fine. I'm currently working on a Fluid Sim and my C++ OpenGL engine for my game. Ooh, that sounds awesome. Sadly, lots of debugging today. I've had plenty of streams that have been the exact same way. And then, it comes time to end it and you don't have a solution, and that's super disappointing. But when you finally get it working, then it's great, right? But yeah, we've certainly hit that plenty of times on this channel. So I'm definitely, now that I'm following you, I'm definitely going to check out your stuff, because that does sound interesting to me for sure. What are the allocators for? So we manage all of our memory allocations within the engine itself, right? So we have two main allocators right now. We'll probably be adding more. But essentially, we have what's called a dynamic allocator, which is basically it pre-allocates a huge pool of memory. And then it, from there, is capable of divvying up from that block of memory to the application, so that we don't have to keep reaching out to the OS to say, hey, give me some memory, give me some more memory, give me some more memory. And all of those memory allocations are tagged. Whenever you... Let me just find the interface here. So whenever you allocate, you essentially have a tag that goes along with that allocation. And then it can divvy up the type of that too. We also have this linear allocator, which we have a couple uses for this, but the idea of linear allocator is, unlike the dynamic allocator, it doesn't have to maintain a free list. So the dynamic allocator you can think as a sort of drop-in replacement for malloc, where we can manage the exact blocks of memory where that stuff actually gets stored. And we have full control over that, whereas the linear allocator literally just moves a pointer forward as it goes. And the advantage there is it's super fast to allocate memory that way, because we don't have the overhead of dealing with a free list or any of that stuff. And we also can't free from it. However, it can be reset. So what we typically use that for is what we call a frame allocator, where every frame, anything that needs sort of dynamic arrays or anything like that per frame, we go ahead and use that one, and it's super fast. And then we also don't have to worry about clearing it at the end of the frame. We just reset that pointer and use that same memory block every frame, right? So that's more or less what those are for. Yeah, you really wanted to solve it today, but it's already 3 a.m. Oof. Ouch, that hurts. Because it's faster to have it pre-allocated, so on PC, it's not so much of an issue, right? On desktop hardware, it's not so much of an issue, but on consoles, memory fragmentation is a huge issue. So eventually, we're going to be able to leverage this so that we can set our operations up to be very cache-friendly. Because basically, by the different tags that we have, we'll be able to separate what blocks of memory those things are allocated to. We're not doing that right now, but eventually we'll be able to. So if I go to K memory, we have all of these memory tags, right, for just different various things. And most of these probably don't matter, right? But some of them certainly will. Like when we go to, some of these aren't even actually used. Like entities, we don't have entities in the system, right? I just kind of built a whole bunch of these up front. But yeah, that's kind of the idea, is that we can then use this to put things in certain blocks of memory together, just to keep things contiguous. Artidos, thank you for the Aretidos? Aretidos? I'm not sure if I'm pronouncing that right. Probably butchered it. Sorry about that, but thank you for the follow. I appreciate it. Let's see. All this stuff looks really interesting. The feature set actually has a lot of overlap with my engine. Awesome. I'm going to have to check out your stuff. Be super interested in that. Do you have professional game development experience or just the hobby? So I developed games professionally for almost 5 years in the web space. So it was WebGL based, right? It wasn't like Vulkan based or anything like that. But and then as I was doing that, I was kind of learning Vulkan on the side and decided to just use that exclusively for my home stuff. But yeah, I did it for a number of years professionally. All right, cool. So heads up, we have ads coming in a minute. And so for those of you guys who are new here, I generally like to pause the stream when ads come up, just so that nobody misses anything. Denton, thank you for the follow. Appreciate that. So at least on the Twitch side, we're served ads every 30 minutes for 90 seconds. So I like to pause the stream whenever that comes up. And that'll be momentarily here in a second. Okay. And then, well, all right. So we have ads. And then I will demo what we have after the ads. Also allows me to hydrate. So we've got about a minute left on ads, and then we'll go ahead and continue. Let's see. Over on the YouTube side, Singyi, hello. Welcome to the stream. How are you doing tonight? Hope everything is well. All right, so got about 30 seconds left on ads, and then we can demo. So it varies by region and locale. So some of you guys are getting the full 90 seconds. Some of you guys get like 30 seconds, and then some of you guys don't get them at all. But I like to pause for the lowest common denominator so that nobody misses anything, right? Because nothing is worse than having the code sort of minimized up to that little tiny screen that you can't see, and then you can't hear anything that's going on either, right? It's suboptimal for sure. All right, and ads are dead. Sweet. Okay, so with all of that said, kind of poor timing on the ads, but I'm going to go ahead and run this, right? So I use NeoVim essentially for my editor, by the way, and I use VS Code right now as my debugger. This is going to be changing very soon, but for right now, it's still the one that I use. So I'm going to go ahead and run this. And I'll pull the window down, right? It doesn't look like much at the moment. And I'll load this up. And essentially what we're dealing with right now, we've got some optimizations that we need to do. But we just recently put a PBR pipeline in place. And so we put PBR pipeline in place. Shadow mapping we also just got recently working. And so this is what we're looking at is sort of the more or less unoptimized version of that, right? And so we're locked to 30 frames a second simply because my refresh rate is locked by my capture device, unfortunately. But what we're looking at here is just a few meshes that I have loaded up. We've got the Sponza scene sort of on the other side of this wall. And then we've got this tree here that I recently added just to illustrate the shadow map cascading through that, right? And so we have the ability to dynamically have lights, which is what we're looking at right now. We've got a height map terrain, and then we've got our Sponza object in here, which is, I'm sure everybody has seen this guy before. And so this one is basically an example of us loading a whole crap ton of meshes at a time. I think this one is almost 400 meshes, all handled individually, right? Because I wanted something that was going to pump up that draw count. So our terrain right now is using 2K textures, and our shadow maps are 2K. And we have a couple of different views here. So we have a lighting only view that's useful for debugging of that nature. We have a normals view where we can kind of get a look at what the normals are for the geometry, which this Sponza object has got some foobar normals on it, which is why you're seeing black there. If we go interior to that, the inside of it looks fine now, right? So we've got that. And then we also have a cascading shadow map debug mode, which looks like this. So the yellow is basically the furthest out cascade, followed by the blue, followed by the green, and then followed by the red at the highest, or the closest, right? And so we have all those different modes of rendering. I'm going to add a few more, like wireframe, things like that. And then we also have the ability to select objects, right? And so let's see, I've got the tree selected there. So I guess I could just move the tree. And so this gizmo, incidentally, is completely written from scratch too. So we've got different modes, like we have just a placement mode, so you can see what you've got selected. We have the ability to move this around the scene, right? Or move it on multiple axes if we wanted to. We have the ability to rotate on the individual axes, right? So we can do that. All kinds of good fun stuff. This needs a little bit of work because it's a little bit hard sometimes to do, right? It needs a little tweaking, but we have the basic tools. We also have scale as well. So if I wanted to, I could make this really big, right? Or really small, right? Whatever. And so, that's kind of the feature set more or less that we're looking at, right? So I have the ability to manipulate all these objects. Now, we don't actually have the ability to write these scenes out yet. These are in a human readable format at the moment. And so those look a little bit like this, right? Kind of looks like an INA file, if you're familiar with those. So we just have the the global scene information here, the skybox configuration, directional lights. This is what a mesh looks like with a transform here. So this is basically its position, and then quaternion rotation right here, and then we have scale, right? So we have Sponza, we have that Falcon car that's there, and then we have this tree. And then we've got point lights in here, and then we've got our terrain, right? And our terrain is basically height mapped, right? So yeah, that's kind of where we're at the moment. The other thing that I forgot to show was we also have this drop-down sort of terminal thing here. So I can, I've got an editable text box where I can edit commands, and I just have some really long text in there, right? But I can Control A and backspace it. I can add text. I can highlight text. I can do all that stuff. And we wrote all this stuff from scratch, right? As well as, we have full support for UTF-8 characters and all that stuff, loading up custom fonts or using bitmap fonts. We have support for all those things too. So if I wanted to here, I could just type exit and it quits, right? This is probably caused by something that I did recently. Looks like we're not killing a frame buffer. Oh, we're not waiting for the frame to be done before it's trying to kill it. So I should probably fix that, but that's not a huge issue. It only happens when it shuts down. But yeah, that's basically more or less where we're at, right? So I hope that kind of gives you guys an idea of what we have going. Let me just see here. Nice of you to put all this work under the Apache license. That's the thing. Like, this is designed to be an educational resource. That's the whole goal of this. I'm kind of trying to create the resource that I wish existed when I was trying to learn how to do all this stuff, as well as show the process of making an engine from scratch, including all the banging your head against the desk and all the foo-bars and screw-ups along the way, and all the frustration, right? Because that's certainly a big part of it. And that's really where the live streams come into play. But yeah, the whole idea of this is it's supposed to be an educational resource, and I believe that stuff should be free, right? There's far too much of it that's paywalled. None of this stuff will ever be paywalled, right? Like, I have the Twitch subs, I have the YouTube memberships, I have the Patreon, all that stuff. But nothing is locked behind any of those. Those are purely for people that want to support my work. I don't paywall any of the content. So all the stuff on my YouTube is 100% free. I don't paywall any of it because I believe all that stuff should be free. And that's basically how I roll, right? I think there needs to be more of that, and I'm trying to motivate people to want to work on game engines and want to work on this low-level stuff because we need more people that can do it, for sure. All right, Lad Spencer and ZZ Ria, thank you for the follows, by the way. Appreciate that. Welcome. All right, so what we were actually kind of demoing there was just some fixes that I put in place around, I guess I can load it up again so I can talk about these things specifically. So before we had an issue where basically the directional shadow map was nuking our point lights. And so I fixed that issue. And then we also are loading in all of our terrain material textures. So we have up to four materials on a terrain right now. We're loading all of those into an array texture, which means that all those textures are contiguous in memory, which means sampling them will be faster. And so we've just completed that whole thing, as well as setting up our rendering engine to be able to sort of make that a little bit easier to do from the front end, as well as optimize our back end and eliminate some code as far as doing that. So we were able to optimize quite a lot of stuff there. We don't have a whole heck of a lot to show for our work in terms of that, but just the fact that we're actually running here is kind of a big deal because we had it ripped apart for quite a while. Let's see. Is there actually demand for these skills in the industry? I mean, things seem to have been consolidating into third parties like Unity, Unreal for a while now. So that's a good question. So absolutely, yes, there is. There are a lot of studios out there that use their own proprietary engine still, because more often than not, those prepackaged engines come with a lot of weight, right? They come with a lot of stuff that you don't need. They come with a lot of stuff that has a high learning overhead or a high cost to maintain. And in terms of things like Unity, you're beholden to them to make fixes whenever you find it, right? Now, Unreal is open source-ish, and so you can access the source of that now, at least, since Unreal 4. But Unreal is big. It's huge, right? Not everything needs that, right? For a smaller, simpler game, you don't need all that stuff, right? Sometimes it makes sense to not even necessarily write a standalone engine, but it might make sense to just write the engine as part of the game, right? My biggest worry about third parties is the ownership and licenses. Yeah, that was the next point I was going to get to, actually. Giving a third party that much influence on your business is risky, i.e. the recent Unity debacle, 100%. Yeah, that was going to be the next thing I was going to bring up, is by rolling your own tech or using something that's completely free, open source, and permissively licensed, you eliminate being beholden to anybody for that kind of stuff, right? If you have the access to the source, you have the ability to fix the bug, right? You're not held back waiting on somebody else to fix that stuff for you. You know how to fix it, and you can fix it because it's your code base, or at least a code base that you have access to. You never have to worry about licensing. You don't have to worry about royalties or any of that kind of stuff if you do something like this. There are lots of studios out there that write their own proprietary engines because they have specific needs that those big box engines don't provide, right? Or don't, provide well enough for their demands, right? One example of this, for example, think of the casino space, right? Casino games are a huge thing online. And a lot of these big engines like Unity have prohibitively expensive licensing for casino games, right? So that's one example of a place where you might want to just roll your own. Like, it's way better to just roll your own, right? But yeah, there's lots of demand out there for this kind of stuff. And I think as things like Unity transpire, people and companies are starting to realize that maybe it's not always such a great idea to offload everything under the third party, right? Doesn't always make sense. So yeah, that's more or less that's my soapbox, I guess, as far as that goes. But yeah, that was one of my main reasons for starting this project a couple years ago when I did. And then the Unity debacle just kind of underscored my point with that. Okay, so with that, let's see, what do we have? Why did my auto mod hold that message? That's bizarre. Okay, so your message that says, "I'm continually amazed that we don't have." Hang on a second. Twitch's UI is covering it up. More supply chain attacks on NuGet, npm, and all those package repositories as well. It didn't flag the word attacks, by the way. It flagged NuGet and npm. The automod is very strange. But yeah, I am surprised that we don't have stuff attacking that all the time, to be honest. Although apparently removing the left pad library can bring down all of npm and the entire JavaScript universe all at once, which is frankly deeply hilarious to me. But I don't know if you guys remember hearing about that, but yeah, that was actually pretty funny. I think it's because the C# package manager is phonetically similar to a no-no word. I mean, NuGet? Maybe kinda, but I don't know. I feel like maybe just like somebody spam flagged it or something. Yeah, it's very, very strange. It's wild to me that anyone would install a package for leftpad. Yes, I agree. What is leftpad? It was literally a library for a... Hold on. You know what? Let me see if I can find it. Let's see if I can find... We find this on a website that doesn't contain a bunch of ads, hopefully. All right, this one looks okay. So, basically the idea is that there was a single package that Node, Babel, and thousands of projects relied on called leftpad, which literally gave you a function to leftpad a string with something, right? And basically this guy just decided, you know what? I'm going to take the package down. And for some reason, tons and tons and tons of people used it. Like, this is all it did. This was the entire package, right? And this kind of underscores my point about, like, the way that the JavaScript universe goes right now is the over-reliance on packages for stupid stuff. But basically, this is all that package contained was this. Right? And it's not even really that well written, to be honest. But it basically just left pads a string, right? That's it. And so, yeah, there's all kinds of fallout from it. But basically, there were packages that depended on packages that depended on packages that depended on packages that depended on this one. And this guy just decided to take it down and just broke everything, basically. It was deeply hilarious. Let's see. This was... when was this? This was a few years ago, I think. Let's see. Does this have a date on it? 2016. Wow, it didn't feel like that long ago, but I guess it has been. Been some time. But yeah, anyway. That was a heck of a tangent, right? But it was deeply funny. The thing that, yeah, it was part of the thing that broke the internet. Yep. Yeah, it's just padding to the left side of a string with a space at a certain length. That's it. That's literally all it does. Yeah, big oof, for sure. Working on an Angular app for my day job at the minute. The basic Hello World Angular app downloads some 200 megabytes of dependencies, and that's only going to go up as you add stuff. I was working on a project, and I can't really say more than that, but I was working on a project that had, what was it, 2.5 gigabytes in node modules? Yeah. 2.5 gigabytes of JavaScript libraries, essentially. Explain that. Explain that. Like, I don't understand, like, what is going on? Had to upgrade my PC from 16 gigabytes of RAM to 32 gigabytes because of node modules. Exactly. It's a bit of a meme, right? Some way, somehow, running those dev servers just eats RAM like crazy. Yeah, exactly. It does. And it's not always enough. Like, sometimes there's like special flags you have to pass to NPM to actually get it to not crash, right? Because half of those packages also leak crap tons of memory. And so, you know, the memory just keeps growing and growing and growing, and then it goes, oh, I've taken 8 gigs of memory. I can't get any more. Peace. I'm going to crash now. It's absolutely absurd. Yeah, it's crazy. But yeah, anyway. Sounds like Chrome. Yeah, exactly. Chrome used to be lean and mean, man. What happened? All right, so get status. So these are all the files that we have changed. And I am actually going to... I think I'm going to consider this branch done, actually. So... fixed various issues around layered textures, path processing, and what else? Oops, change log. Let's see, what else did I put in there? Oh, and the issue about point lights with shadow. And an issue where directional shadow maps canceling out point lights. Good enough. Okay, so push that up. That's probably going to take a few seconds. Let's see. All right, let me catch up on the YouTube side here. Nice sprite. Hey, finally caught you. Nice. Welcome. I know I'm getting to these messages a little bit early. It's because I was on my soapbox. Sorry about that. This has really come along. Awesome. Yeah, it has. It's come a long way. Will it support realistic day-night cycle clouds, weather system? Eventually, yes. Yeah, a lot of those things are actually on the roadmap, although not all of them, but Those are all systems we're going to put in for sure. I'm working on a model loader, and I'm confused about is the inside material file in 3D model. Is it holding roughness metallic values of PBR or Phong shading properties? Or what, so I can load them correctly. So if you're talking about OBJ file format, there's actually, believe it or not, there's a specification on Wikipedia for this that tells you what all these various properties are. So I'll drop this in YouTube chat as well as Twitch chat so that you guys can see that. So hopefully that helps. Shy, hello, welcome. You find that Unity engine does not load all models correctly. Do you have an idea about this? I have not used Unity in years, so I can't speak to it. Hello, welcome. I'm not 100% sure how to pronounce your name, but I'm going to say Ian. Ian Nguyen. I'm not 100% sure. I wish I knew how to pronounce those symbols. Okay, yeah. So if you're talking about OBJ, you'll probably want to have a look at that link that I. Let's see. These properties are not PBR properties in OBJ files, so they can be, right? Typically, like you have diffuse, specular, specular highlight, right? These are Phong, right? But if you scroll a little bit further down, it can also include these maps, right? So you can try to translate them as you see fit. But yeah, as far as what I'm doing right now is I'm basically taking some of the Phong properties. So like I'll take the diffuse texture map and I'll treat that as albedo, right? And then I take the bump map and I'll treat that as the normal, right? Displacement I'm not supporting yet. But yeah, I'll extract those two and handle those. I don't do anything with the specular because that doesn't really translate, right? And then I have defaults in the engine that I use if they're not provided. All right. Let's see. Firefox eats a lot of RAM. Sometimes it's lean, sometimes it's not. 100%. Yeah. For anyone interested, there is a small and incomplete list of custom engines on a gist called A Small State-of-the-Art Study on Custom Engines. I saw that the bot told you not to post a link. So what you can do is if you go onto the Discord server, which is a link in the profile, and you drop that into Kohi chat, I'll see it. Currently going through the course you put up on YouTube. Oh, wait. No, currently going through the course put up on YouTube by Dave Churchill, so it'll be a while before I get to anything as complex as this engine, but it's nice to see other people doing similar stuff. Okay, cool. Yeah. And take your time with that so you have a full understanding of it, right? Okay, let's see. So what is the next step? All right, yes, that's what we actually need to determine. So there's a couple things that we need to take a look at. So let me go actually. Let's look at our roadmap. So a lot of what we've been doing is revolving around PBR lately and optimizations once we put that in. So there is probably one more thing that we need to do in terms of import of materials, but I think that maybe can wait. Yeah, see, here's sky sphere and dynamic day-night cycles. Somebody was asking about that. So one thing that we do need to get to sometime soon is our terrain, right? Because our terrain is one huge, gigantic mesh right now, which is obviously not ideal. We really need to add chunking and culling to that, and then afterwards LOD and tessellation. So that might be something we look into. Visibility and inclusion volumes might be nice too. Just as a nice optimization. Let's see what else. Yara, thank you for the follow. I appreciate that. Let's see. We got shadow maps done. We also have some different rendering modes we need to experiment with at some point as well. I'm not going to touch UI for a while. That one we can X off. We have what we need for that for now. The other thing that we might touch is this. So our job system right now is basically you can fire off a single job, and then you have a callback when that job completes, and you can do stuff. But we don't have any sort of job dependencies, and we also don't have any sort of semaphores or signaling as to when those jobs are complete, right? We just have that callback, which isn't always what we want. Theoretically, we could get job dependencies by using our callbacks to then kick off another job, right? But it'd be nice if we could like configure that in one place and set that up, and then just fire off the thing, and it could just do all the jobs and then come back and finish that. To do that, though, we need thread pools, which we also don't have. Our job system sort of has its own internal thread pool, which we could maybe then use a thread pool for this. But like the idea behind a thread pool that I'm thinking about is you might have like our current terrain texture loading essentially loads 12 textures from disk and jams them into that singular block of memory for the arrayed texture. It would be nice if we could say, okay, split out a thread for each one of those things, and then wait for them all to be done, wait for that entire pool of threads to be done, come back together, and then put it all together, right? So that might be nice. We have an ad break. So we will figure this out when we come back from ads. So just for anybody that's new, I like to pause the stream whenever ads come up on Twitch, which is once every 30 minutes for 90 seconds, rather. Just so that nobody actually misses any content, right? Because nothing's worse on a programming stream than having ads on the screen. You've got that little preview off to the side there, and then you can't hear what's being said or discussed, right? So I like to just pause the stream for a second, hydrate, and then we move on. All right, so we got about 20 seconds left on ads. Almost done. All right, and ads are dead. Sudoths, thank you for the follow. Appreciate that. Welcome. Asking about PCF. We already have PCF, actually. We already have that implemented, actually. Did I not? Yeah, PCF's already in there. We're already currently doing it. Yeah, I mean, we are going to expand on that and add a few other algorithms to it for like soft shadows, but for right now, yeah. We also do need, I should add to this actually. We do need point light shadows, which is actually, that was something I forgot to discuss. So I mentioned cube map arrays. We actually do need to support cube map arrays, which shouldn't be a huge deal at this point, actually. Minimal Vulkan code, I'm thinking, and minimal renderer code. But we're going to need that for point light shadows because you need to be able to render to cube maps for that. So that's probably, oops, I marked that as done. Yeah, it's not done yet, but we need to add that sometime soon too. But I can hold off. I'm comfortable holding off on that for right now. GDC had an interesting video a couple years ago about the multi-threading in Destiny. Yes, I saw that video. I know which one you're talking about. It was super interesting. And actually, funny enough, I tried implementing their whole view system that they talked about in that, and I ultimately backed it out because it was just way too constraining and complicated. But there were some other really good talks about that. So yeah, it was still, I gained a lot from it, for sure. You're going to implement Cube Map Shadow too soon? Yeah, nice. Yeah, that's definitely something we need to do. And I don't think that's going to be too hard. So let's see. I just really have to pick something. Well, the first thing I should probably do, I push this, right? All right, let's go ahead and let's clobber this branch. Let's get this merged in. Let's get this merged in. All right, so we want to merge this into just the feature PBR branch. Right, and so these are all the commits that we've done for layered textures. It's not a crazy amount of code, right? But it's, well, it's a lot. Some of these are collapsed too, I think. But yeah. So let's go ahead and merge this back into the base feature branch. And we will squash and merge that. And nuke the branch. Come over here. PBR. Oh, I modified the to-do. Annoying. Forgot to push that up. All right. Check that out. Git stash pop. Yeah, it's literally the only thing. Okay, perfect. All right, so now we're back on the PBR branch, which we actually need to merge into main sometime soon. I think, actually, maybe we should just go ahead and merge that into main at this point. Because, essentially, everything that we've done in 0.5 is all been on the PBR branch. So, like, this is what this feature branch entails. Which is actually a lot of stuff. So I think this is probably where I'm going to draw the line on PBR. And then we can start focusing on some of this other stuff, right? Because some of this stuff just doesn't make sense to actually include in this branch. So I guess, yeah, let's go ahead and do that. So at least all of this stuff is on the main branch of code finally. So let's go to here. I can only imagine how large this is going to be with all that stuff. All right, so 15 commits, 218 files changed. Just a few things. Just a few things. Some of these are collapsed. Yeah, to be fair, there's a lot of this is materials as well, right? Image files. I'm not going to scroll all the way through that. Okay, so let's create the pull request. All right, and then I'm going to bypass my own protection because it's me. That's mainly in there if somebody else commits, right? All right, we will squash and merge. And nuke that branch too. So, oops. Now everything is on our main branch, which has been a long time coming, right? And actually, I probably should update these screenshots This is still our Fong lighting, right? So this is what our lighting used to look like. Just to give you guys an idea of how far we've come with our lighting enhancements, right? Quite a difference, I would say. Hey, coders. Hello, Max. Good to see you. Wondering who would be doing a code review? Me, myself, and I. Yeah, that's mostly for PRs that other people have opened up. Quick hi, have fun, everyone. Good luck with today's stream. From Lake, thanks. Appreciate it. Sudoth's first time chat. Great stream. Thank you. Appreciate that. Let's see. Let me catch up on Twitch chat here because it looks like I missed some stuff. All right. Oh, wow. I've missed a few things. All right. Cool. Are semaphores a thing with hyperthreading? I mean, hyperthreading isn't really it's not really exposed that way. It's just threads, right? It's just like multi-threading. You have semaphores that can go with that, right? That gets signaled when the job is complete, right? So yeah, you can use semaphores with that. We don't have them in the engine yet, but eventually we're going to. Have you looked at any of the stuff of Handmade Hero or maybe even learned from it? Yes. Yeah, I watched that series probably about, I don't know, I want to say probably 100 or so videos in. And I wasn't able to keep up with it because I kind of, started doing my own thing and started this, right? But I do check in every once in a while on it. And yeah, it's interesting. The first part of that is really packed solid with information for sure. It's a really great resource. Nice approach. Thanks. Yeah, appreciate it. Appreciate that. Thank you. Let's see. What do you need in Vulkan that's not available in modern GL? It's more so about the fine-grained control that you have over things. Vulkan is more close to the metal in terms of how GPUs actually work, whereas GL sort of abstracts a lot of that stuff away for you, which is good from the sense of, it makes the API a little bit easier to work with, but it's bad because you have less control over it. And OpenGL is not multi-threading friendly, right? There are ways you can multi-thread it, but it was never really designed for that, right? And pretty much everywhere OpenGL is deprecated. And I say that with the asterisk of deprecated is not the same as obsolete, right? It's still very much alive and well, but it's not being updated anymore. It's not the future of the way things are going, right? Everybody's going towards these very verbose, specific, explicit APIs, right? Vulkan, DirectX 12, Metal, they're all very explicit APIs. That's the direction everything is going. Vulkan's getting updates. OpenGL is not. It's just the way it is. Let's see. Is there a difference that distinguishes Vulkan and similar game engines from game engines such as Unreal and Unity? No. And most of the big engines also all use Vulkan under the hood. It's not really about renderer features so much as it is about how resources are dealt in communication with the GPU, right? It's not really about resources. Or it's not really about features, it's more about resources, resource management. Yeah, OpenGL is really high level. Vulkan is really low level in terms of control. Save me, I don't know how to answer these questions. Yeah, I think I pretty much covered it. Yeah. 95K lines of code. What's 95K lines of code? I wouldn't say OpenGL is really high level. It is compared to Vulkan. Granted, I have zero experience with Vulkan, but at the end of the day, OpenGL 4.6 is pretty much just uploading buffers and writing shaders. Yeah, and that's why it's high level, right? Because you don't have to deal with anything like managing descriptors or manual synchronization of memory, right? It is super high level by comparison, trust me. I know that Vulkan gives you more control, and it gives you some things that are even impossible with OpenGL, like RTX ray tracing. That's a big one. We're eventually going to do that, right? But for games that don't use those specific features, I'm wondering if there's literally any actual benefit. So I think the answer with most things in programming is it depends, right? And the reason I say it depends is it depends on what you're doing, right? If you're writing a small, simple 2D side scroller, then probably you don't need Vulkan, right? You could probably still get away with writing OpenGL just fine, or a simple 3D game even, right? But if you're going to be targeting, newer types of features, right? If you want ray tracing, or if you want high performance with the ability to tweak that stuff per platform, things like that, at a micro level, you're going to need to use Vulkan, right? And also, I would say the other advantage also is that ultimately Vulkan is the way of the future, right? Or Vulkan-like APIs are the way of the future, right? If you just stick in to keep using OpenGL, what you're likely going to eventually be using is, I think at some point, GPU manufacturers are going to start not directly supporting OpenGL, and OpenGL is basically going to become a Vulkan wrapper, essentially, and it's just going to be translated under the hood at some point. I suspect that's what's going to happen. So even if you're using OpenGL, you're going to wind up using Vulkan anyway, eventually. I don't know how you feel about generative AI, but I've had some promising experiments using it for code review. It's not perfect, but it's oftentimes better than coworkers who don't really care to read things carefully anyways. I have very mixed feelings about AI, especially when it comes to code. I have not once gotten something from an AI that was usable, performant code. There's always either security issues with it, or it's not performant, or it just flat out doesn't compile sometimes, right? And I'm not saying that the code here in this engine is necessarily the most performant or isn't riddled with bugs, right? This is very much in development as well, right? There's plenty of bugs with this that eventually will be ironed out, right? But yeah, I'm still pretty skeptical of it. I haven't really seen a whole lot that's been generated by AI that I could actually use. For a programmer, depends is the most correct and least satisfying answer. Such as the curse of programmers, 100%. Yeah, I hate giving that answer, but it's true, right? OpenGL is the highest level of low-level API. I guess I could agree with that. Yeah. Just implemented MIP mapping in my software renderer. I'm learning that trilinear filtering using distance isn't the best approach. Yeah, I can imagine. I've never, I haven't implemented a software renderer. That's one of the things on my list to do one day. Never attempted that, but it sounds super interesting, right? Something I've always wanted to try, just haven't had the time. Skynet is soon. Yeah, I know, right? Okay. Cool. So we've done that. We just need to pick our next thing that we're going to work on. Since we've been working with terrain, I'm thinking maybe terrain chunking is the next thing that we tackle. Because we're kind of still in that mindset. And so maybe that's the thing we go with. I do want to do the job system and multi-threading stuff, but I think I'm going to have to do all that at the same time, and I think it makes more sense to jump to terrain chunking for now. So, where is it? Here we go. So chunking and culling is what we're probably going to do next. So the idea is, and I'm going to bust out the best graphics editor ever here. Just a second. All right. All right, cool. So the idea here is that we have this huge terrain, right? And right now, we've basically got like our sponza here, and our little car mesh here, right? And our little tree there, right? And this actually isn't even to scale. Like if you actually look at this, like in the shadow maps that get rendered, it's actually like about that size, the whole thing, but whatever. The whole point is that most of what we're doing is kind of around this general area, right? And so our view frustum, at least when we start, is like something like, is this going to allow me to, yeah, I guess I'm going to have to freehand this, whatever. Is something like this, right? And this is obviously not to scale, right? And actually it's way farther out than that, right? Goes something like, I don't know, like that, right? And so the idea is that if this is all the terrain that we see in here, why are we rendering all this? So the idea is that when we load up our terrain, and I'm actually going to make this in, let me switch colors here. I'm going to make this in larger pieces than it needs to be. When we load up our terrain, we split it up, right? So we'll just do, I don't know, I'm freehanding this. It's not to scale, right? And so we might do something like this, right? And each one of these squares is a chunk, right? And maybe if we zoom way in, like maybe these chunks are like really small, like this, right? And so the idea is that we would essentially only want to render chunks of this terrain that we can actually see. So we would render this one. We would render this one because this intersects here. This is our view frustum, right? We'd render this one, this one, this one, this one, this one, this one, and this one, right? But we would only render those out of all of these, which is a huge performance boost, right? And then the other aspect of it is, let's say we're facing this way, right? And I'll try to make this roughly the same schedule, or the same scale, right? Let's say we're facing this way, looking more or less out over the terrain, right? And so sticking with our example from before, I'll just split these up again. Sorry for the crappy drawing, but I think it gets the point across, right? And so in this case, we can't, this terrain beyond here is clipping anyway, right? But it's still technically being drawn, right? It's still being sent to the GPU to say, hey, draw this, right? And so what we really should be doing is just drawing, again, these guys, right? This one, 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 right? And so we can save a lot of time by just drawing only the grid pieces we need, right? And so that's going to be what we're going to implement, is slicing this up, right? Instead of doing this as one big thing, we're going to slice this up. And the way that we're going to do that is typically our entire system is based off of right now, an image that is of a certain dimension. So we have a height map, right? And typically that's like, I think it's 256. 256, right? And 256 here, right? So 256 wide and 256 high. And so what we're going to do is we're going to determine a chunk size, which I'm thinking is going to be 16, right? And we'll divvy this 256 up into 16. And so whatever our chunk size is, our dimensions will need to be a multiple of that. And if it's not, we'll throw an error, that kind of thing. We're not doing any checking on that right now, so we're going to need 2. So we'll have maybe a configurable chunk size, right? And then the image needs to be a multiple of that chunk size. And then as we're loading, we're essentially going to split all of these into separate pieces of mesh data with their own sets of indices and their own sets of vertices, right? Which does mean you're going to wind up with some duplicate geometry, right? Because if we take a look at, if we assume that this is just one triangle, right? Or one quad, right? So let's just say this is one quad for a second, but it's got quads next to it. In order for those to be separate, you actually have to duplicate some of these pieces. So this vertex here, and this vertex here, and this vertex here, and this vertex here are actually duplicated once for each one of those tiles, right? So we do have some duplicate data. We do have some indexing changes we're going to have to make as well. But I think, you know, once we figure out what that is, it'll pretty much make sense. And this does come with its fair share of issues as well, which we will address when it comes to LOD. But doing LOD, level of detail, will be a lot easier if we have this in place first. So this is the direction that we're going to go next. Let's see. To-do list is inspiring. Yeah, it is. It's what keeps me going, honestly. So I appreciate that. I had high hopes for WebGPU as a middle between GL and Vulkan, as the API is nice. The WGSL shading language and no support for something like SpurV is a shame. Yeah, that's a huge shame. That's bummed me out, honestly. It makes me not want to touch it. But more than likely, what I'll do is I'll just treat it as a target for our custom shading language that we're going to eventually write. I found a software renderer to be very fun, but some of the coding can be quite tedious and prone to human error, mostly off by 1 or sign errors. Yeah, I run into that crap all the time too. Yep. How do you separate those meshes into such clusters? Oh, it's a terrain based on an image. Yeah. So is it nanite? No, it's not nanite. This is basic terrain chunking. This has been around for decades, right? As long as 3D terrains have existed, pretty much you've had to do this. It was even more important back in the day. If you tried to throw this terrain at a GPU from 15 years ago, it would have choked, right? So yeah, we're basically it's height map based right now. That's just our method of generating it. But the terrain data, essentially, once it's generated, won't care where that data came from, right? So eventually we're going to have the ability to like import and export terrains and maybe even from a mesh, right? I haven't decided yet, but yeah, we're going to have lots of different things that we can do with terrain. Terrain is a huge topic on its own. Do you think there are any benefits to using DirectX 12 over Vulkan on Windows? Driver optimizations, perhaps. But I would say driver optimizations and also probably the ability to port it to Xbox would be another one. This is gold. I appreciate that. I do stuff in Unreal Engine since the engine takes care of such things. You don't have to really get into that deeper. Yeah, exactly. So this is for people that want to go deeper, or at least understand it, right? Vulkan doesn't run on consoles yet. It runs on the Switch. But yeah, Microsoft is not going to support Vulkan, right? They're not going to put that on the Xbox. No way. I don't know about the PS5, actually. Yeah, the Switch does support it, though. Yep. So does Android, obviously, if you consider that a console. More or less these days, it kind of is. All right, so let's open up. If I can spell terrain correctly. So we have 2 components, but the terrain loader is probably the primary one that we need to be concerned with. So And we have a to-do in here for a binary format. So that's actually, is that on the to-do list, I wonder? It is not. That's kind of a big one. We should add that. So we need a binary format similar to what we do for our static meshes, where when we generate a height map terrain, we then save off all the generated data to a binary format, which can then just be loaded directly the next time we actually load up the engine. So that's probably something we should tackle. But I'm glad I haven't tackled it yet, because I'd have to rewrite that along with this. So the Switch based Nintendo, yeah, exactly. That was a super based move. That and the fact that you can get a dev kit for it for $400, which sounds like a lot of money. I mean, it is a lot of money, right? But like not compared to getting a dev kit for consoles and what it was in the past to even rent them, right? Surprised there hasn't been more Android-based devices such as console. Yeah, the Ouya, or the, what the heck was it called? There was one years ago that kind of flopped, but yeah. There was one, but yeah, there's not really, not recently. But I guess phones are kind of that too. Other people probably use their phone more for that than just emails and calls. Yeah, exactly. Cheap for a dev kit, yeah. Yeah, exactly. $400 for a dev kit is based. I mean, you obviously have to go through the application process and sign NDAs and all that stuff, and you have to be approved for it. But yeah, eventually going to be porting to this to that once we have a couple games released on it. Will this culling take the camera pitch into account or only the yaw? It'll take all of it. So it's actually going to use the view frustum, right? So the frustum is basically what we use to generate that perspective view, right? So this is a badly drawn frustum, right? But it takes all of that into account. Ads again, dang it. Time is flying by tonight. So every 30 minutes on Twitch, we're served with 90 seconds of ads. So I just like to go ahead and pause the stream whenever that comes up. So we got a little over a minute left. I'm going to hydrate some more, actually. About 30 seconds left, and then we can jump back into it. Posture check. Yeah, thanks, Raz. I appreciate that. My posture is terrible tonight. I'll feel it later. Ads are almost done. All right, and ads are dead. Cool. So let's start looking at this a little bit. And I may actually split this off into its own feature branch in case it starts getting big, but we'll see. All right, so the terrain loader load. This is what actually loads up the resource. So we get the file path, we open the file. Incidentally, so you guys know what we're actually looking at. We have these k-terrain files, which is sort of a terrain configuration file. So this is metadata about the terrain itself. So this is where we can actually potentially use binary data or height map data or different ways of generating this. So there's this height map file in here that if set loads height map data. Once we actually have a binary file format, it'll probably check for that first with a matching name to this. And then if it doesn't find that, it'll load this up. So we have our X and Z scale, and then our Y scale, and then our materials that we set up here. So these materials are references to materials that exist over here. Right, so let's see, river rock for one. And this is what actually contains all of the material information. So all this stuff is copied over and used as part of the terrain, right? So we could just reference materials that way. And so what we'll need to add to this is we already get the size of the image from the image itself, right? But we need to do chunk size. So we'll add a new parameter. And I'm going to say 16 for right now, because that's a nice divisible number, right? And I know it lines up nicely with 256, right? We could do 32 or 64, but I think those chunks are going to be a little bit too big. So we're basically going to take 16 pixels at a time of the image and create chunks of terrain based on that. Let's see. Pretty sure my back will have a 45 to 60 degree tilt when I reach old age from slouching in my chair 8 hours a day. Yeah. I try not to do it as much anymore, and I actually have a standing desk that I use during the day. I raise the desk up. But, yeah. I'm already starting to feel it. I feel like once you pass 30, things start breaking, right? Okay. So, add chunk size here. So that's a nice and easy first thing to add. So basically the way that this parser works is it goes line by line through the file. It splits each line into var/value. So we have a value here, which is the var, and then it equals, and then the value on the other side. Everything in here is that way, except for comment lines, which are skipped. And so we go ahead and split on the equal sign, and then go ahead and get the var and value out of that, trim it, sanitize it, all that good stuff, and then process the variable. So let's see. We do have versioning in here. I'm not so sure that I'm going to increment this version yet, because we're not really doing anything that's not really backward compatible yet. So what I'll do is I'll probably also default the chunk size to 16 in case it's not provided. In fact, let's actually just say not provided defaults to 16, right? But I'll leave this there anyways as an example. So let's see. I guess I'll just take one of these things. Actually, version probably makes the most sense to take. So I'll just copy this and put it here. And add an else to that. And then instead of version, it's going to be chunk size. So this is a case insensitive comparison there. We are going to store it in version, which we don't have yet. So let's see. That's probably going to be here towards the top, I'm guessing. Yeah. So we'll do U32 chunk size. And we'll default that to 16. All right. And so chunk size will write to chunk size is a U32. And then format error, invalid, chunk size. Defaulting to 16. And then just to be safe, if that set it to anything foobar along the way, we'll go ahead and just set it to 16 just to be safe. All right. Okay, so that's our chunk size. So now we have the height map file is actually loaded. Let's see. So we load the resource. We do all the calculation of the pixels data. Let's see. Do we actually do that yet, or are we just, I think we just read height information actually from that. Yeah, okay, so we just read height information from that, which is fine. Image data. So we should probably store off the width and height, because I don't think that we actually have that yet. Let's see. Okay. So yeah, we probably should store that off somewhere. So let's do U32 width. Let's actually call that, it's like a tile width. I don't know if I want to call it tiles. Grid width. And height. Actually, let's go with length, I guess. If I can spell. Width by length. Because height is actually going to be the y-axis. Yeah, we'll go with, actually we'll also store that. But we'll, you know what? Maybe we'll store that as extents. I'll come back to that. Abran, thank you for the follow. Appreciate that. Physical activity is good for you and a good diet. Yeah, I'm addressing both of those things. Definitely trying to do a better job of that this year. Got to lose some weight. You know, you got to put on the winter coat for winter time. But then you got to get rid of, you know, shed the winter coat. It's time to shed the winter coat. Okay, so let's store off. I guess we'll do, have this from here. So we have the image data here. Let's store off the grid width as the image data. Oops. Really, Vim? That's not what I wanted you to do. Why are you importing C++ libraries, Vim? But why, though? Shouldn't be doing that. Fail. All right, image data. This should be width. Right, and then grid height, or what was length? Image data. That's image data height. Right, so we'll save those off. And then here we have, let's see, if we don't have a height map, we just generate some default data. And it looks like we go 100 by 100, which is not. Oh, wait a minute. We have a tile count X and a tile count Y. Yeah, we're already storing this. What am I doing? Okay. We can eliminate those then. We already have those. What we should do here is, let's do a if you know what, I should probably actually add to the resource data. This is probably where I should add that, right? Yeah, let's go ahead and add U32 chunk size here. That way I don't have to copy it later. Okay, so we'll do resource data chunk size, and then resource data chunk size, and get rid of this one up here. Save that straight to the resource. And then we'll verify if resource data chunk size. Actually, let's do resource data tile count x mod chunk size is not equal to 0, or resource data tile count z mod resource data chunk size is not equal to 0. Right, then we don't have something that's divisible evenly. So we'll need to bleat about that and basically abort the load at that point. VSM2718, thank you so much for the Prime subscription. I appreciate that. Welcome. Let's see. I have a question that's completely unrelated to the topic of your stream, so feel free not to answer if it's crossing a boundary. I'm curious about your thoughts on using your full name as branding. What you're doing here on here and on YouTube. It's kind of just the way I started. So, I don't know. I've never really thought much about it, to be completely honest. I feel like it's easy enough to find somebody's full name anyways. So, I don't know. It's also unique, right? Like, nobody else is going to have my last name out there. Like, and also as a YouTube channel, right? And even my first name is actually more rare than you might think. So I figured it was unique enough where like I could get a domain for it easily. Right? That's actually, you know, I guess that was kind of my thought behind it. That's about it, honestly. All right, so if we hit this scenario, we'll say height map dimensions must be a multiple of chunk size. And then we'll output what those things are. So map width equals, and then we'll output an unsigned. Height equals, and we'll output a unsigned int. And then chunk size equals, and we'll output another unsigned int. And I guess we'll just do this. Right? And so we'll do, we actually split this up a few lines because it's getting kind of long. All right, so resource data tile count x, which is also the image dimension. Resource data tile count z, and then resource data chunk size. Right, so this this must be true in order for this chunking to work. Otherwise, we're gonna have to deal with like chunk sizes that are chunks that are weird sizes and weird dimensions that aren't square and all that stuff, and I just don't want to deal with that, right? It makes much more sense when we're generating terrain like this that it just has to meet that requirement. All right. That also means, though, that down here on our height map, we were generating 100 by 100, and that's also not going to work, right? So we're also going to change this to 128 for a default, right? So it's a multiple of 16. And then we'll also do resource data chunk size equals 16 here as well, right? And basically all this does is if we don't have a height map that's supplied in here, it just generates a flat terrain. Because we want to do what we can do to avoid crashing the engine over stupid stuff, right? But this definitely will abort the load. So we will return false on that one. Fair enough. No need to overthink a simple thing. Yeah, exactly. Because that's going to make it even more complex when we have to think about LOD. So I just don't want to deal with it. We can always enhance it later if we want to do that, right? But why? All right. So we have the height information here. Which did we... Yeah, we stored that in a one-dimensional array, so I guess we have to transform that back to a two-dimensional array when we actually go to process it. I wrote this code a while ago, so I'm refreshing my memory as we go. And I'm also going to fix this annoying thing that my auto-formatter did at one point, where it split some stuff to multiple lines where I really didn't want it to. Okay, so that is all that has to be done in terms of loading the terrain from a file, right? The rest of this is actually handled in the load process of the terrain object itself. Because once we have this data, we can actually generate the geometry from it that we need. That's probably going to wind up changing when we switch to using a binary format, because we're not going to have to calculate any of that stuff. But I think for now, I'm going to leave it like it is. So we do that, we unload the resource, and then we set the out resource data, and whatever called it has it. Perfect. All right, so let's open up terrain.c. Okay, so this is terrain create, which takes in the configuration object that we would have just loaded from the file. We take a copy of the name, tile count X and Z. We also need to figure out, we need to take in the chunk size. And we can trust that this has been verified by the loader at this point. I think, I mean, technically we could set a chunk size of 1, right, if we really wanted to do that. So let's just say chunk size cannot be less than 1. All right. Set the transform, set the extents. Calculate based on actual terrain dimensions, and that's a to-do. Okay. So this is actually something that's interesting, because this is the extents for the whole terrain. But we're also going to need extents for each individual chunk. Speaking of chunks, we should probably also determine what that chunk looks like. So let me think about this for a second, because there's a couple ways that we could tackle this. So basically what we're doing right now is we are the terrain itself has vertices and indices, right? And in arrays that it holds on to. And that's basically for the whole terrain, which is fine. But when we actually need to chunk this, that's going to be different. And so my first thought, and the thing that I'm leaning towards wanting to do, but cautiously because I think it's going to bite me if I do it, is basically just pointing to sections of this array. No, I'm not going to be able to do that. Never mind, actually. Not even going to bring it up because it's going to be confusing. We have to rewrite it. That's fine. So let's actually take a look at the terrain structure, because we're going to have to modify this guy. So this takes tile count X, Z, scale X and Z, and scale Y. Those things are all fine to leave here. These are what needs to be moved. So this, the extension origin can stay here, but we're going to need those for each as well. And the vertex and index count. Actually, the vertex data, I don't think we're going to need to keep that around either. Maybe, maybe not. I suppose I could split those up how they're used as well. And then we also have this geometry that we essentially load all this stuff into, right? So we have all of this data that loads into a geometry. This geometry is what gets fed to the renderer to actually render the thing out. And so, let's see, material count and material names. I guess we do still kind of need that, unfortunately. I might see if I can do away with those being stored there. Okay, so what we really need is a new structure. So we'll say type def struct terrain chunk. We don't really need the chunk size because that's going to be stored here on this guy. Although we haven't copied that over, so we need U32 chunk size. So each terrain chunk is going to need, at a minimum, these things. So we need vertex data, index data, and a geometry for each. We'll also need extents 3D, extents. Origin, I don't think we need, because our vertices will be based or generated based off of that. So I don't think we need that. Okay, so this I think is going to cover us for right now. So we have terrain chunk, and then down here we are going to have a U32 chunk count and a terrain chunk array chunks. And the way that I'm thinking of setting this up is probably row by row, then column by column. Right? Row by row, then column. So in other words, it'll be like 0, 1, 2, 3, 4, 5, 6, 7, like chunk IDs, right? 8, 9, etc. And so we'll do this as a single dimensional array because we can very easily translate that to a multi-dimensional array under the hood, or get the index for an XY. So I'm not really too worried about that. data structure wise, that should give us what we need. All right. I'm going to get rid of this second view over here for a second and then go back to this. Let's see. So after this, let's do our out terrain. Chunk size equals config chunk size. Let's see. Just had a major facepalm moment in trying to find out for the last 3 hours. Forgot I rolled back an NVIDIA driver update that had an HD audio update. Oof. Why your Bluetooth wasn't working? Ouch. I hate that kind of stuff. Driver issues are annoying. Driver issues are actually the reason I'm on Windows right now instead of Linux. But yeah, I digress. Okay, so we're taking this is where we were creating our vertex and index data before. So ultimately what we need to do now is say out terrain chunk count is going to be equal to config actually I can, yeah, config tile count x divided by config chunk size take that and multiply it by config tile count z multiplied by config, or divided by config rather, config chunk size. Right? So that'll give us the total number of chunks we have to have. Adds. Okay. So for those of you who are new here, I like to pause the stream whenever ads come up so that nobody misses any content. So this is especially true over on the Twitch side. Over on the YouTube side, I know you guys don't get served ads the same way that Twitch does. But on Twitch, every 30 minutes we are served with 90 seconds of ads. And so I like to pause the stream when that's coming up so that we don't have people missing stuff, right? It's only 90 seconds. That's not that big of a deal. We're already halfway through it, right? So try to take ad breaks as a opportunity to hydrate too. All right, so got about 25 seconds left. I think the advertisers I know only buy food and things that have utility because the only ads I get on Twitch are for food. That's funny. I mean, they probably do know, right? Okay, cool. So I think ads are dead. Yes, they're dead. All right. So we're going to quickly bang out this section of logic. So we have our chunk count there. And now we can say out terrain. And we can go chunks. And we're going to say kallocate size of terrain chunk times out terrain chunk count. And the memory tag for that is going to be array. And then we can loop through each one of those chunks and initialize our arrays of vertices and indices, right? So U32 I equals 0, I is less than out terrain chunk count, and then plus I. Terrain chunk pointer, we'll just call this chunk, equals address of out terrain chunks sub I. Then we can do chunk index. Well, let's do vertex count, right? Yeah, let's do vertex count first. So vertex count is going to be the out terrain chunk size squared, essentially. Out terrain chunk size times. Actually, no, it's not going to be times anything. It's going to be, yeah, just that. Right? And then chunk vertices is going to be k allocates size of terrain vertex times chunk vertex count. And again, memory tag array and chunk index count. Oops, index count is equal to out terrain. Actually, I think we could just use the vertex count for this. Chunk vertex count times 6, I think. Vertex count or that doesn't seem right to me. This should actually be chunk size times 4. And this should be that times 6. So let's do this. U32 chunk size squared is equal to that. And then chunk size squared and chunk size squared. All right, and then chunk indices. K allocates size of U32 is our index type times chunk index count. Memory tag array. One of these years I'll quit hitting F1 when I mean to hit the 1 key. All right. Let's see, what else was there for the terrain chunk? We have extents, which we can't calculate until we calculate the height. The geometry we can't really do yet until we load the geometries. Okay, so that's all we can do for right now. So we set up the memory for each chunk. Oh, this should be indices, not index count. All right. So set up memory for the chunks. Okay, so that does away with this. I'm just going to comment these out for right now. Let's see, vertex data length. Out-terrain vertex count. This actually makes me think that this has probably been wrong for a long time. Okay, so this should probably be Out terrain. Actually, let's do config. Tile count x times config tile count z times 4 for the vertex data length. And then we just reuse that. That's for the vertex data's the height data. Right. Okay. And then we have geometries. Oh, we need to invalidate the geometries for each one of these guys. Okay, we can do that. So this needs to be chunk. Chunk. All right, cool. All right, so now that we have that, the next step is going to be to actually load up the geometry. Actually, we should probably take care of destroy. It's actually kind of hysterical I have this here. Should have gotten rid of that a long time ago. All right. So this and this can actually be done within a chunk. So it's going to be this if t chunks. We want to make sure that it exists first. And then we'll do for u32i equals 0, I is less than chunk count plus I. And loop that as well. And then we'll do terrain chunk equals address of t chunks sub I. So do that. Let's replace that and that. Vertex count as well. We just free these things up. All right. We got the vertex datas. Oh, okay. So we put this here. And this one. Oh, I just got those backwards, didn't I? Just move this one down here. Okay. So we zero that out. Cool. So that's our destroy. And then our initialize is going to be the next thing, right? Oh, this is going to be a fun thing to re-implement too. Okay, so here's the vertex generation logic. And this, unfortunately, is where I'm going to have to start, or where I'm going to have to stop for tonight. Because I have to get up early in the morning and redo this for chunks. So this is what we're going to hit up tomorrow. Because I have to get up early tomorrow and I can't be up any later. It's already 11 o'clock here tonight. So oh, I did all this crap on the PBR branch. Seriously? That doesn't even exist anymore. All right, let me save everything. Stash. Pull the main branch. It's ultimately not going to matter. All right. Stash pop. Merge conflict in to-do. That's awesome. Okay. It's deeply hilarious, actually. Yes, it's the... Oh, it's almost the same thing. All right, so we need the binary format. Oh, I marked terrain as complete. That's why. Well, base terrain is complete. I'm all right with that. Okay. All right, so that's good. Cool. All right, so let's do get checkouts. Feature terrain chunking. Chunk. Oh, forgot the B flag. Add get commits. Work in progress. Terrain chunking. All right, and this way, there is a terrain chunk branch available on the repo for you guys if you're interested thus far. We haven't done that much code tonight on this, but it's there anyways in case you guys wanted to look at it for some reason. Let's see. You don't get ads. What's wrong with you? Yeah. So ads actually vary based on region and locale. And also platform. So some people get the full 90 seconds. Some people only get 30 seconds. Some people get none whatsoever. It just varies, right? If there's no ad to fill that slot, it doesn't get filled, right? Let's see. Let me just catch up with chat here real quick on YouTube. How to handle the case the camera moves from ground to sky. Many far unloaded terrain chunks that need to be visible with low details. So that is all stuff we're going to handle. We're not quite there yet, right? We're going to chunk the terrain first, then we're going to worry about culling, and then we're going to worry about level of detail, and then we'll worry about popping those in and out of memory, right? But we're not there yet. All right. Thanks. It was fun watching you code. Awesome. I'm glad you enjoyed it. Yeah, if you guys haven't already, definitely toss me a follow here on Twitch or over on YouTube. Those follows definitely help me grow the channel. So I'm looking to reach more people, bigger audience. The more people I can reach and convince to write engines, the better, right? So I appreciate it. And let me see. Who can I raid for the night? You know what? I'm going to, since I can't actually stick around tonight, I'm going to raid. Thank you guys for the follow, by the way. I'm going to raid Ferret Software because it is it's a ferret rescue that is run by Pirate Software here on Twitch. And basically the idea is that he takes ferrets in who are in conditions that are so dire that generally it would lead to them being euthanized. And he's able to medically rehabilitate them and get them back to a healthy state and save their lives, basically. He's got about 20 of them now, and he uses the proceeds from the channel. The ad revenue alone is enough to pay for all the food and medical care for all of them, and that's insanely expensive, and it's still enough to actually cover it. So it's a great cause. I like to support it, and that's what I'm going to do. So I appreciate you guys. Thank you very much for being here, and I will see you guys tomorrow night when I am streaming. See ya.